Okay, hi to people joining us. We are looking at some designs related to trees.
Oh, I should have looked at this agenda before. This is the old version where there are lots of examples, but no, don't close it.
You need to give a new version?
I mean, there are examples, but they're inside those bullet points. So,
Oh, so should I just open everything?
yeah, probably.
Okay. So what are we, now I'm going to scroll through the whole thing. What are we basically looking at here?
First, we have a bunch of LCC things with expressions, and then we have the redesign of ExpressionTree.
Okay, now remind me why we're doing this. And is this, okay, give me a little bit more background here.
Right, so there are various differences between how, sort of functions that operate on expressions and their tree counterparts differ, which may or may not be correct.
So this is to do with head handling or to do with part counting or what?
Well, it's showing, I mean, with respect to, I mean, all sorts of things. I don't think I can narrow it down to the,
Okay, fine.
Bullet points. Right, which I guess is not necessarily an independent question from the tree redesign, ExpressionTree redesign, but so, right, so here's sort of, one sort of big difference, for example. Right, one might expect if you give it a span rather than getting, I mean, I know maybe this doesn't make any sense, but right, it's sort of weird that, right, extract, if you give it a span, it preserves the head, right? If you give it two separate positions, 2 and 3, you'll get a list 2 and 3. But if you give it a span, then you preserve the head.
Do 3 levels of list and just do 2, 3 instead of in separate lists. With 3 levels of list.
What? Oh, what do you mean?
Yes, 3 levels of lists. So
list at of that.
You mean?
Yes.
Yep, like this?
Mm-hmm.
Yep. Right, so that's...
What the heck is that?
That is the same as what you would get if you did list of 2 of the span.
Right, that is a single position spec, which is a list 2, 3, and therefore behaving the same as part. It's giving you one part, and the part that extracted is the part list 2, 3. Right? So if you do part of F ABC, comma list 2, 3, that's what you get.
Mm-hmm. But okay, so the issue is, what could this, is there a way to get it to include the F here?
So let me try to rephrase. So in the extract language, we have lists that represent position. So it's like wrapping levels, and lists that represent multiplicity.
Mm-hmm.
And extract is treating them differently. In tree extract, currently, we are treating them equally, always returning lists. And so Itai's point is that one of them should return another tree head. And I think in this case, I agree. I agree we should change that in tree extract.
If you scroll down a little bit, there's a proposal of what that would look like. And I think I agree with it. Tree extract can preserve the data.
I'm totally confused by this. So
in a sense, we are returning lists of children. Itai is saying, in that case, also return a tree that contains the the common ancestor, the common boundary.
Exactly.
So what identities are supposed to be true? Is there an identity that says you can treeify an expression, do this, and then come back again?
If we made this change, then yeah. If you did extract of an expression and then converted those expressions to trees, you would get the same result as converting the expression to a
Okay,
tree.
so the identity that we have
Extract.
is extract
Of
of
yes, of expr comma spec.
Mhm.
Um,
And
then
map
that whole-
map expression tree across that.
that's equal to tree extract of expr comma spec. Is that right?
It's not it's not.
If we make
slash
this
at, it's
change.
at, right? It's wrapping extract the on the left hand side.
Oh, expression. The first argument of tree expression needs to be expression tree of expr.
Right. So
Right,
let's start over. Expression tree at at extract of expr comma spec
Okay.
should equal tree extract of expression tree at expr comma spec.
Yes, that is true for that would be true for a single position if we preserve the data.
What about for multiple positions?
There would be map.
Okay, fine. Okay. I mean, on the face of it, seems right to me to do this, to make that identity be true.
I agree.
Okay, onward. Tree map at.
So the issue here is that tree map applies the function to the data. So we wanted to follow that for tree map at, but that causes there to be some confusion. If you have a position that ends in 0, are you referring to the position? Like, are you referring to the data at this position, or are you referring to a position that itself is a position within the data?
Wait a minute. Usually the at simply refers to a tree location. You can't sort of breach the expression boundary and start referring to subparts of the expression, can you?
Right. So it's like map applies the function to the whole sub expression, but tree map only applies the function to the data at that position. And tree map at follows that same precedent from tree map. But the problem is that the data of a subtree is technically a different position from the subtree at that position.
My God. Okay. All right. Let's try this again. All right. So what you're saying is usually tree map at says go apply this function f at a particular location. Normally that location, but it's applying the function f to the data at that location.
Exactly. It applies it to the data at that position, whereas map at applies it to the sub expression at that position.
I understand, but if what was specified at that position was in fact a subtree, what then happens? If you hadn't got all the way down to the bottom of the tree and you said tree map at a partial location.
It just applies to the data at that position without affecting the children.
Oh, I see. So it only ever applies to data.
Yes.
Okay. So then what's the question? So
the issue with that is because it applies to the data, that's implicitly adding a 0 to the end of every position spec. Like, so we say tree map at position 1.
Okay, so your point is a tree.
Position 1, 0.
Right. A tree doesn't have the same part numbering as the expression underneath the tree.
Yeah, the data is position 0. So if you have a position and then you say 0, that moves into the data. And then
I understand, but that's because the tree expression, the actual expression, tree of tree of tree of tree of tree, whatever, right, is close to the part numbering of its part numbering is close to the part numbering. Okay, I'm sorry. The logical part numbering of the tree is close to the literal structural part numbering of the underlying expression, but it isn't exactly the same.
Right. So position 0 is the first argument of tree, and then positive positions are the corresponding positions in the list of children.
Right.
Right. And right. So, I mean, and I think this really comes to a head if you look at the third input. So you'll notice the first input, the first two inputs where I start with 1 and then 1, 0, I get the same thing because the first one, it's not applying it to the tree, it's applying it to the data, and 1, 0 is explicitly the data. But then we do this additional.
I know, I understand. Okay, I don't think I think there should be a rat wall, so to speak, to prevent the rodent burrowing into the head. I mean, into the data of the tree. In other words, I think tree map at should just have specifications of tree elements and nothing more. And it doesn't even need, that 0 there is irrelevant.
So positions ending in 0 would just be prohibited.
I think so. I think that and I think the idea of a mixed tree map at and map at is crazy. I think if you want the thing to go into the data and then map at a certain position in the data, say tree map at, whatever.
Mm-hmm.
But the main utility of this is to modify the data of the trees, right? So by doing that, we would be forcing everybody to do those combinations of functions.
No, but wait a second.
Oh, that's assuming that the function they're applying is map at and not, just f to some, right?
Yes, I mean, I think that the
perhaps I misunderstood. So I think the important point here is that the function is still mapped on the data. Whether it can borrow inside, yeah, perhaps we don't do it.
I don't think we should burrow inside. I think it should be a, fully rat wall, so to speak. No rodent burrows further down than the actual tree itself.
I think that makes sense for tree map at. My question is, tree extract does support extracting out of the data, but I think that's probably less problematic if we keep that behavior.
I think it's a little weird.
Yeah, I mean, I also, and I think there's a section on tree extract, and that one is weird, but it's less. I agree, it's less problematic. I still think it's very weird.
I think that it might be safer to just disallow it right now. And if we find we keep on needing it, let's think about that later.
So I'll just pull out support for position 0 in these functions.
Yes, don't allow them to go in. Don't allow them to burrow into the data.
Yep.
I mean, it's very weird. If you have zeros here and then the zeros mean a different thing, they mean heads inside the data, it's just going to get really weird really quickly. I mean, this is a tree extract because it is doing tree-like extraction rather than doing expression-like extraction.
Yep.
Okay. Deleting a head. Deleting a head is weird.
Right. So this is something that's not yet implemented, and or is that something that now evaluates?
Well, so right. Currently, position 0 is only supported in any form in tree extract and tree map at. We don't support it in tree delete. And the question is, do we want to support position 0? And if so, what should it do?
You mean it blows away the data? Yes, I think it is useful.
There's two choices. It could blow away the data, or it could do what delete does and delete the actual node there.
We're talking tree deletes here.
Yes.
Yes. Right. So what's in the comment is the input, and the thing that's actually evaluating is the faked output.
Okay.
Right. So in one case, it just makes the data disappear, leaving an empty node. And in the other case, it blows away the node and all its children become children of that node's parent, which is what delete does on expressions. And I would favor the latter.
The blowing away the thing and making everything the direct descendants of its enclosure.
Yes.
What happens if it has no enclosure?
Maybe in that case, it just replaces it with null, kind of.
Right. So just like we special case right when there's a special case for when you delete the head of the whole expression and it replaces it with sequence. So we'll have to special case that, and it'll be a node with no data in it, which I guess we use null for that.
I have to say once again that these things seem to me like they're sort of semi-bugs. By the time you get to deleting the head of the top of the whole tree.
I do feel like deleting the head of subtrees is a useful operation that we don't have another way to do.
Wait a minute. So tell me again what it's going to do. So tree delete of a particular tree location will blow away that tree location and reroute its...
No, so tree delete of a regular position will get rid of that node and all of its children. But if the position ends in 0, then it would just get rid of that node and its children would become children of its parent.
Oh, that's really weird.
Which we don't have another way to do.
Right.
It's tree surgery.
But that's also right. I mean, that's also analogous, right? That's completely analogous to what expressions do, right?
Yep.
If I have f of x of 1 of 2 of 3, and I blow away position 1, I blow away that whole x of 1 of 2 of 3. I don't just blow away the x. But if I blow away the head at position 0, then I'm left behind with that nested argument thing.
I think we have a meta question here, which is probably the idea of the whole discussion here, is that expressions have been a main model for trees, but perhaps they shouldn't be a completely kind of compulsory model.
Yes, I think they should not be.
Exactly. If we find something more useful to do in some case, perhaps we just do that other thing rather to be forced to follow expressions.
Yeah, I agree.
Well, do you have a suggestion for what's the more useful thing?
I would remove the data, not the node.
Well, my view is that removing the node is more useful because we don't have a way to remove the node otherwise.
I think we should have another function that removes the node. I think having the node removed by putting a 0 there is just frigging weird. I mean, I almost think like, okay, so tree delete normally deletes subtrees. That is its normal life.
Yep.
This is, which is what delete also does normally.
Yep.
So, I mean, tree delete node, we're calling them nodes, right? We have functions that call them nodes. Is that true or not?
Tree element or node.
What do we have that's node? I mean, we have.
We're not using the word node in the name of any functions.
Okay.
The ones
but tree delete element.
Tree element in the name of functions, like tree element style.
To me, tree delete element makes more sense, where we just say we give the location of an element and kaboom, it disappears.
Tree element delete. I think we have tree element in multiple places.
Okay, fine. Tree element delete.
I mean, delete can even remove the whole expression. You can do delete x, comma, double empty list, and it self-removes itself.
That's like our previous discussion. What does it
No.
No.
You need to set another empty list,
Exactly.
right? You need
Well-
a list of empty positions, not a single empty, right? That's no position specifications. If you double list, it's a list containing one empty specification.
Oh my gosh.
And,
You know,
and tree delete does this as well, and I think it's right that it does.
that does what?
If you do tree delete and have a double empty list, you get sequence.
But here it's because you are removing the whole tree.
Yes.
No,
And
not
that's
just
separate from replacing the head with sequence.
Okay.
Right, right. Empty list is the position corresponding to the whole expression. So you've just said delete the whole expression. So tree delete of double empty list is delete the whole tree. There can't be
Yeah.
much left behind.
Yeah, I get it. I get it.
So it sounds like we're saying also don't allow position 0 in tree delete and have a separate tree element delete that deals with that case.
I'm sorry, I spaced for a second. Could you say that again? Tree
It sounds like we're saying tree delete also should not support position 0 at all.
that's
We
correct.
should have a separate function tree element delete.
Right. So tree delete deletes subtrees. And it should say that. And tree element delete deletes elements of trees. And replums the tree. Reconnects the tree. Does that make sense?
It's a bypass operation. We
Indeed. Right. It's tree surgery. It's some kind of bypassing of pieces of. I hate to even imagine.
fog nodes.
What's that? Yes, right.
Fog nodes.
Right. One day, no doubt, there'll be a way to do that for bronchial whatevers. Anyway. Okay. So I think that's that one. Okay. Tree insert. No, it really shouldn't do this. It really should not. It should not breach the tree leaf boundary, the tree data boundary. Okay. So is there any more to discuss about tree insert?
I don't think
I
so.
don't think so.
Okay, expression tree. Are we on to this?
Yep. So the key thing from last discussion was we identified that the two shapes that we care about are heads goes to true and heads goes to false. And then all of the other questions are about what do we use as the data. So I have 4 base cases and then 2 options that affect all of those cases. Well, 2 and also heads.
Okay, so hold on. The thing that I'm most keen on for my practical uses of trees is I want to display the tree without a lot of greenery. Do I now have a way to do that? That isn't crazy.
So we're taking 2 approaches. One is if you have, you want to specify a different structure that has what you want specifically in it. And then the other one is having options that allow you to easily say, I want, like, don't show me any inner node labels or
Look,
color.
I want to
everything.
take this and I want to make it into the analog of, I want to make it display more or less like that, but in the tree formatted
Yep.
way.
Okay, so I think that is a separate discussion that we've already discussed it and it's straightened out. We're gonna have tree element function, tree element style function, tree element shape, all of those options, and then you'll be able to do this easily.
Okay.
But this is the question of how do you actually make that initial tree and specify all the different combinations of that.
I see. From an expression,
Directly
right?
from
You're
the-
taking apart an expression and making a tree from it.
Yep.
Right, and just to be completely clear about our previous discussion, those identities only hold for certain mappings, right? You can have, some of these ways of forming trees from expressions will not preserve the identities because you can't simultaneously satisfy the identity, multiple
Exactly.
mappings. There is no centralizer to the group of mappings from expressions to trees.
Wait a minute. Sorry. Say that again. What can you not? I got distracted again. I apologize. What can you not satisfy?
We wrote an identity above with tree extract, and it's just not. It's only going to hold depending on what expression structure you use, because otherwise you'll have.
I see. I got it. Yep, I get it. I understand. Okay, so the question here is, what is the expression we're doing this with?
It's the expression
That
you see
thing there.
Yeah.
Okay.
And so the top row is with heads goes to false. The second row is with heads goes to true.
So, okay. So what we're saying is the data at every step contains heads, sub-expressions, or only, I think, why isn't that leaves?
It's the atoms of the expression, just like the heads and the sub-expressions of the expression. I feel like leaves is referring to the tree.
The heads of the, oh, I see what you're saying. Yes, I see what you're saying. Yes,
the names are kind of like pour all of the data from the whole tree into a bucket. What's the word that describes all of it? Like the first tree.
Well, I know. But one question is, presumably there's a level spec for ExpressionTree. Is there a level spec for ExpressionTree?
Can you?
Right now there isn't. Are you saying only go down?
You mean like what tree form has like an in, like a max level?
Yes.
Yeah, we could have a max level.
I think it should, because I think that
not a full level specification, but like a maximum level of tree to build.
Correct. Yeah, the other way around.
It's like it's a tree depth or
yes, it's tree depth. Right. It's how deep you go in the expression and treeing it out. So you're not going down. I mean, I can also imagine it being useful to have excluded forms.
Yes, we will.
Okay.
I was thinking about that for the binary decision tree. Like you say, excluded forms is not, and then you get the right expression tree.
Okay. Right. Otherwise, yeah, I mean, so for example, some I've been building, we've got X blank as a leaf, effectively. And if you don't exclude pattern, you're, toasted.
Okay. Is there a null version? Is there a null version of heads goes to true?
Yeah, I just didn't show it.
Okay.
And all this does is to zero out the data in every place.
Mm-hmm.
This shows the same structure. This shows the tree of the expression, but we're zeroing out all of the data.
Yep.
Okay. Well, this seems okay. I'm okay so far.
Then the proposal is we'd have options tied to specific structures instead of to expression tree, since expression tree is going to have lots of different structures.
What do you mean by that?
So here I'm specifying heads goes to true in a list with the sub expressions.
What?
Because the second argument could be XML, and that's going to have different options than expressions.
So what? I don't think it should be in a sublist. Why is it in a sublist? That's really obscure.
Because it's not an option to expression tree. It's an option to the structure.
Yeah, but we do that in import, for example. We have, options. It's sort of a polyoptional function. Do you see what I mean? depending on whether whether you're a GIF or whether you're a, I don't know, an audio file or something. You have different options for import. I think it's okay to do that.
Directly to import?
To ExpressionTree, yes.
Okay.
I mean, it would be a matter of supporting them.
Doesn't hold sub expressions also actually apply to everything? Right? Why is this specific to sub expressions?
What do you mean?
This next item here. Does it apply to atoms or heads as well?
Yeah, it's an option for all of those structures.
Okay, so then blow away the braces.
But not for XML, is what
I
I'm
know,
saying.
but it's okay. So we just ignore it in that case.
Yes, so the important point here is that we can support that, but then it's documentation that becomes more complicated. For example, import has all these options, but if you do options of import, you get nothing.
Right. But right, because import has those special.
We may end up wanting documentation pages dedicated to specific structures.
That's what I think too.
Instead of having ExpressionTree be super complicated.
Yes,
Exactly.
that's what I think too. And I think by the time you get XML, so what are you imagining that the XML import looks like? An XML expression. You're going to say ExpressionTree of the XML object.
Comma, string XML.
Fine, although you probably shouldn't need the string XML. What is it going to do by default in one argument form with an ordinary expression?
What it currently does.
Which is what?
Convert everything fully to a tree.
Which is the case of atoms or the case of what? Which case here is the automatic case?
It's heads with heads goes to false and with recursive ExpressionTree goes to true. I have it there.
Okay.
One of the.
So I think that it should be automatic by default, and I think it should depend on the first argument. And I think we should try and do some sensible things that possibly aren't that.
So have it like detect which structure to use.
I think so. And I think, for example, if what you have in the
first
first element there is a whole collection, I mean, I would even say if it's a whole collection nested lists and then below the lists are random other things, I would say that there's an argument that it should treeify down to the end of the lists and not beyond by default. Because that's what's going to be useful. And it's rather hard to specify.
For arrays.
Yeah, well, and might
But
be
if
useful.
you had an array and you wanted to actually look at the expression structure, you'd have to. So then that would be you'd say something other than automatic.
Yes, but I think there's an argument that ExpressionTree should have a specification that says go down to the bottom of the lists. It's different from things.
Yeah, I think we should have a specific structure that's just called list or something like that. That's what it is.
Yeah, I agree with you. And another one called arrays, which is the full depth array.
Mm-hmm.
Okay, so let's look at this. So I don't think these should be string options. I think we should figure out how to make these non-string options.
Okay.
So what does hold sub-expressions do?
So it wraps things in hold form at like the last step where it needs to wrap them in hold form to prevent evaluation.
You mean inside the data?
Yes.
Right, because
which is not necessarily just wrapping the data in hold form. Like if you have recursive ExpressionTree goes to true, the hold forms are going to be deeper inside, which is why I have this as an option.
Oh boy. Okay, well, I think I understand hold sub-expressions, but I feel like that's an option which is similar to options of other functions, and I'm trying to understand how to unify it with that.
Why is it not just wrapping the data in hold form?
So for example, in that recursive ExpressionTree, the payload will still be a tree. It won't be a hold form of a tree.
Oh, okay.
Which is necessary in order for part extraction and all that to still work.
Okay, but I'm asking again. I think there are other functions which have this property that it is they are sort of recursively holding things, sub-expression holding. In other words, for example, doesn't extract have a third argument that is what it does? You know, hold, for example, is a third argument of extract.
Well, the difference is that, you know, extract, right. I mean, extract it, you know, right, since it's done in C code, extracts without evaluating, and then it can choose to wrap each result in the optional third argument, so you can prevent it from evaluating when it's returned to you.
Right.
Yes.
And level has an optional argument that wraps all of the results instead of wrapping each one individually.
Okay, which is analogous to what you want ExpressionTree to do. Is that correct?
I think neither's. It's more like what extract does, but with extract, you're saying where are the things you want to extract, and where you're wrapping the hold form depends on which structure you're using, whether you're using heads or sub-expressions or.
Okay. All right, let me understand recursive expression tree. What does that do?
So normally heads would be like the actual sub-expression, and recursive expression tree converts anything other than a tree, converts it to a tree using the same options recursively.
I think you mean, well, right, any compound head is converted to a tree rather than being stored as a compound.
If the head is a compound expression, yes. If the head is a compound expression, then you apply expression tree to it.
Why isn't that heads goes to all?
Heads is specifying which sub-expressions have a corresponding tree. And this is controlling the data instead.
I understand, but if heads is false, then you're not going into the heads.
You can have this option for both heads goes to true and for heads goes to false. It's independent.
I don't understand. What if heads is false, it will never go into the head.
No,
so
if
how
heads
does it
goes to false, then heads do not become subtrees.
Compared to the trees above.
Yeah.
In both cases, you have f of AB. So Ian wants to convert those into trees.
You would still go into the head. It's just it doesn't become a subtree.
In which case would you go into the head?
Right.
Heads
So
goes to true or false,
remind us, the
exclusively
top row is
false.
heads goes to true or heads goes to false.
The top row is heads goes to false.
Right. So you have f of AB, that's the compound head, and you just see its children. In heads goes to true, right, that f is repeated as a head to the
Right. You see in the second row, the first item, there's one of the children corresponds to the head.
Second row, first item. This one here.
Yes.
right. So then
It has a child that corresponds to the head
Of f of AB.
Yeah.
of f of AB of g of 1, 2, x.
What? Okay. In
Right.
this
So-
case,
Look at the
so
whole
the root,
expression
right, the
of
root-
f of b
the-
of g
the-
of 1, 2, x.
right, the root, right, yeah. So in the middle item, you see the whole expression. It's f of AB of g of 1, 2,
yeah, I
comma
see
a.
it. Yeah.
Right. So in the leftmost tree, the first one is the head of the overall expression. Then you go down one, and rather than just seeing the children of the head, you see f repeated as a head. And then you have,
Right. Why do you repeat the head?
yeah, why do you
You can
have-
go from heads goes to true to heads goes to false by just deleting the first child of every subtree. That's the only difference between
Well,
heads
but
goes to
I
true.
would have thought that heads goes to true would simply ask the question, do you go inside the head, period?
So my reading of this is that subexpressions is the easy case to understand, and then to preserve the same structure as a tree, but just changing the data, heads does that, which is a bit
The
arbitrary.
string heads refers to the different data. The symbol heads is controlling the structure of the tree.
Right, yeah, so maybe you should
Yes.
compare the second item of the two rows, right? In one case, you just have, right, you don't see F of AB anywhere. But in one case,
Right, but so if heads goes to false, I wouldn't expect to see the F of AB.
Right, that's heads goes to true.
No, it's heads goes to false.
The second row is heads goes to true.
Yes, where it says heads goes to true and heads goes to false, that's a bit confusing because that section is only heads goes to true. Heads goes to false is the previous section.
Yes.
Exactly.
Okay, that's exactly what I would expect. Capital heads, this heads goes to true. If heads goes to false, it doesn't go into the head,
Mm-hmm.
right? Okay, now the recursive expression tree
Refers to the data. So does not care whether you have the full sub-expression or the head. It just converts the data to an expression tree.
you're saying it converts the data inside the tree.
Yes.
Is that useful?
It's the default for current expression tree. And the reason I chose that is so that it satisfies the identity about position specs that we said earlier, to where the position specs of the expression tree correspond 1-for-1 with the position specs in the expression.
But that's breaking the rat wall, isn't it? That's allowing that position spec. When you have a subtree, when the data is itself a tree, you have to break through the rodent wall, don't you? To get into.
It's like I've replaced every compound expression with a tree.
Yes, I understand. But to be able to use tree extract to go down into those, to be able to use a single tree extract to go through the upper level of the tree, then you hit the rodent wall, then you go into the data area, the data enclave there,
Mm-hmm.
and start burrowing into the data.
Right. And just
Okay,
like an
so-
expression, the head is either atomic or a compound expression. Here, the head will either be, or here the data will either be an atomic expression or it will be a tree.
I understand, but what I'm saying is tree extract shouldn't allow, if there are 3 levels to the outer tree, then you hit the rodent wall, then you go into the data. I claim that a single tree extract should not be able to have indices that refer to both of those things. Does that make sense?
Basically, like what we were saying earlier, like don't support position 0 in anything.
Yeah, that's what I'm saying. Don't let you get in. Don't let you jump from tree into, it's kind of like there are creatures that live on the outside of the tree, and then there's kind of like the maggot, whatever they are, the whatever the heck those things are that burrow into trees. I don't think we should. I think that the inner life inside the tree is a different thing from the stuff that's hanging in the canopy outside the tree.
This is a bit of
Sure, but this function also isn't doing burrowing. It's just converting an expression into a tree. And this is.
I know that. I just don't think it should do it. I think that if you want.
We have had the opposite discussion when we were considering operator forms, and we were trying to use tree form on operator forms, and it never did the right thing. It never did the right thing because it wasn't able to enter the heads and represent.
I know, but
tree.
heads arrow true can go and headify to its, heart's content.
Heads is controlling what children there are. Recursive expression tree is controlling whether the heads get turned into trees inside the data.
I mean, they are two logically independent options because
They really are.
Okay, so hold on.
You can
One is
have-
whether it goes into the heads. I'm sorry, I'm really not getting it. Is it the case that this breaking
What
apart
heads
of
is whether it goes into the heads. Recursive expression tree is whether the data is converted to a tree.
whether the data where is converted to a tree?
Everywhere.
right,
Data of
anytime
every
you have
node
a
is converted
compound
to an
expression
expression.
in a node.
Yeah.
So in other words, what's the reason that ExpressionTree would not have converted things? Maybe it's level spec. If you say go only to level 2, then things below level 2 are non-converted
No, it's like
expressions.
look at heads. Look at the very first one. You say heads, and the root node contains an f of AB.
Yes.
That's the case I'm talking about.
Case for what? Where it isn't converted.
Yeah.
Right, it didn't
Convert
go
that
into
into
the
a tree.
Okay,
head.
but I want you to, the case I'm mentioning, where you only go down to level 2, then every lower level is also not converted. But if you had your recursive expression tree thing,
I see.
then even those lower levels that you thought were not converted will actually get converted.
Maybe it only applies to inner nodes then,
What do you mean by inner nodes?
not leaves.
How can an inner node of expression tree not be treed out unless it's either hitting the depth limit or it's a head? I don't get it. I don't get how it can ever fail to treeify other than by being a head. Otherwise, it's a
right.
normal. Okay, so then what I'm claiming is that the cases are.
But last time you said you wanted an option so that you could do the same thing for sub-expressions as well, which is why currently we just have a separate standalone structure called head trees, because that's the interesting case. But you could imagine doing this for sub-expressions, and then you would be turning every sub-expression into a tree, not just the heads.
What is head trees? What's that?
Head trees is the current, like in 12.3 or in 13.
Name for what?
The default expression structure.
Oh, I see.
And it effectively has recursive expression tree goes to true. Last time we discussed this, you mentioned why does that only happen for heads? And maybe that's this discussion we're having now. But it could just as easily be done for sub-expressions.
How could it ever?
At every node.
What?
But then you have the tree of the full sub-expression at every node.
Of the full below it sub-expression.
Mhm.
Okay, I'm finally understanding. Okay, so in the case of sub-expressions, where you have a big blobulous expression at every node, there's the question of, is that expression then rendered as a tree in the node?
Yep.
I see. It's kind of trees all the way down or not.
Exactly. Go until there are no compound expressions left.
So this is something that is clearly more useful for heads goes to false, which is the situation implicitly in tree form, which is where this discussion started.
Yep.
This will become less useful in heads goes to true, because as you said, there is already the heads represented as a child.
Okay. All right, we got these two options. Really what this is, this recursive thingy, is tree elements become trees. Is that a fair statement?
In some sense, yeah. Like the data of tree elements.
Yeah. Trees all the way down. No. We can't have expression tree with an option called recursive expression tree. It's a self-referential function with its own option. It's like
It's an fractal.
It's what?
It's a fractal tree now.
Yes, right. It's, oh gosh. Okay. So a tree element. What this is saying is convert tree elements to trees. Convert the data of tree elements to trees.
Yep.
Or alternatively, it's really data expressions. Expressions that appear in data, will they become trees? That's what we're answering, right? Expressions that appear within
compound
data.
expressions as data, what happens to them?
Well, there's a compound expression of things with semicolons.
No,
we can't use the word compound expression because a compound expression is a function that is the
compound expression is the name of a function, but also the terminology for non-atomic expressions is compound expression.
I thought it was normal expressions, but I admit normal expressions isn't beautiful. Where do we say compound expressions? Do we use that terminology? I mean, we use it informally, I know, but I thought we were avoiding that because compound expression was named as the sequencing thing. Okay, in any case.
I know what you mean.
Right. Okay, so the issue is, does every sub-expression turn into a tree? Well, I mean, look, I can imagine something called sub-expression trees. I hate that. It's inside a function called expression tree, and then we're saying sub-expression trees. What is the name of the thing? Is it tree element data or it's tree data, right?
Yep.
The data as tree or tree data as tree goes to false or true.
Data trees goes to true.
Obscure. Tree data. Convert tree data to trees. I understand the concept now, finally. By the way, does it go down?
Kind of like the tree analog of the heads option. Like we don't have the corresponding thing for tree, like go into the data.
Yeah. Does it do it recursively? I mean, that is if it's a tree within a tree within a tree.
Yep.
What does it do?
Keeps going.
Really? I mean, it's not obvious that that's the right thing to do. If we have oh, I see what you're saying. You're saying.
So I only had that as the default for the correspondence with position specs. But if we're getting rid of position 0 for now,
yeah,
that's not a good argument for it being the default.
It's really render data as trees. It's something like that.
Yeah, I like that.
I don't like the word render though.
Render's misleading. It makes me think that it's only formatting that way.
Yeah. Trees for tree data. Sounds like some kind of environmental campaign. Tree.
But it's a rendering thing, right? So it would be more like render trees data as tree.
Yes, that's right. Except for the word render, which we don't tend to use.
Yes.
Render in the sense of transform.
Yeah. How about something like use trees for tree data?
But I'm not confused. So is this deciding whether to insert three symbols?
Yes.
Or just-
If you have that option, this will actually change the data to be a tree instead.
So then it's more like use trees for non-atomic heads.
Well, no, because for the data inside a tree. What it's going to be is it's going to be a tree.
This
whose
specifically
tree
only
data
applies to
element-
inner nodes that have compound expressions as their data.
Right, but in the end, the structure will be a tree whose payload is a tree.
Yes.
Not its children, but its payload is a tree.
But this is the option that is deciding whether that payload is going to be a tree or not.
That's
Yes.
correct. Hence, saying for tree data. Well, I mean, there's another possibility, which is tree data representation goes to trees expression. It's another possibility.
Do we just want to have head trees like we do now? Just as a base structure and not have it be an option? It's irrelevant to atoms and for null. And it's not very interesting for sub-expressions.
I don't understand why head trees. No, that seems like the wrong thing. I don't, because those other ones affect only. I don't know. I don't know. I mean, my favorite so far is use trees for tree data. Represent tree data with trees. Tree data as trees. Tree data as trees doesn't seem absolutely terrible.
Yeah, I like that too.
Okay.
So hold sub-expressions will be hold tree data, arrow true or false. Is that true?
Say that again. Sorry.
It's like hold atoms.
What's hold atoms? Where is there hold atoms?
No, it like I'm suggesting that as a name. Like the hold forms get wrapped tightly around the atomic expressions, not around the data.
What do you mean around the atomic expressions? Atomic expressions are in the data. They're in the data part of the tree, aren't they?
I'm saying if you have a tree as the data, you don't wrap the tree in hold form. You go into that tree itself.
Okay, so that's the interaction between tree data as trees and the held sub-expressions business.
Yes.
Right, but if you have a normal compound expression as data, I hope you just
Make
yeah.
it,
So if you have recursive expression tree goes to false, then it's just wrapping all of the data in hold form. But for recursive expression tree goes to true, or tree data as trees goes to true, then it keeps going into the trees until it finds atomic expressions and wraps those in hold form.
so it's really hold tree data, arrow true or false. Is it not?
Yep.
Are you sure that there isn't? I mean,
maybe we should.
I think it
have
should
hold
be
form wrapped around a whole tree, but
look, I think it should be something like tree data wrapper, tree data. What's the right word for wrapper? And then you could say hold or identity. I think that's more general because that way we can have hold form, hold complete, whatever else you want.
okay. And this would still interact the way I'm saying, like drilling into the trees.
I think so.
Mm-hmm.
Is there a reason why this couldn't be an optional third argument?
That's what I would think it would naturally be based on extract and so on.
Well, I think the third argument most likely will be the max level.
Oh, yeah.
And I still think this makes sense as an option because it's not for every kind of structure.
Okay, but is there a precedent for something that is called a wrapper here? We've got that, I think, in lots of places. We've got things that wrap results, and we've got a name for this, and I'm trying to think what it is.
I think we normally call it function, right?
Oh, yes, that's right. Tree data function. That would be the natural thing to call it. It's just a function to apply to tree data, which actually, I think there could be all kinds of useful functions to apply to process the tree data when you extract it.
So what I'm calling the structures, like the string structures, are the function to apply to get a tree, and we're talking about the function to apply to the data afterwards.
That's correct.
Okay.
Actually, I'm confused why tree data as trees isn't simply tree data function arrow and then a tree making function. And then why isn't this that arrow expression tree?
It's like expression tree with the same options as the outer expression tree.
Okay, well, that's a different
issue.
issue.
And also, right, that's only applied to normal expressions, not to atoms.
Okay, fine. But it's very similar to tree data function as expression tree, arguing again for a tree data function because I think it's a general useful thing.
Right. I mean, we could theoretically have like a special named string, right? Just like the color data function can be a named string for.
Yes, that's a good point.
We could have a special string that represents, or maybe automatic could be.
I like that idea.
The other thing is that as independent options, you can specify hold along with expression tree. If we just had a named like string expression tree, how would
is that useful to do the named along with it?
I'm saying, how do you do a recursive expression tree? And
I know, but is that useful?
hold.
Because I mean, you're where are you holding it? You're holding the atoms.
Mhm. Regardless of if you specify a wrapper, expression tree is already careful about not letting the expression evaluate. So it's purely a question of once you've stored the thing in the tree, what do you wrap it in? And that's why it's only needed for the atoms.
Well, I think you should have a little think about whether tree data, whether with several strings, including held atoms or something as a string or some such other thing, we could avoid the tree data as trees.
Mm-hmm.
And just have a tree data function, because I think that's clearer. I think people will understand the tree data function does something to the tree data as it inserts it. The description is this is a function to apply to tree data when it is inserted in the tree.
Yep.
And one of the things you can do is turn it into and one of the special cases is you can turn it into a subtree. Tree data function arrow subtree or something.
Yep.
Okay, I think we nailed it.
So the only two options would be heads and tree data function.
That's what I think. I think it's nice.
Mm-hmm.
Yep, I think we've covered everything, and those are good functioning.
And we would have these four structures and not have like expression as a structure. And these are subcases.
Right. I could imagine we could have additional structures.
Yeah, structures. I think so too. I think there could be
Actually, these are basically tree data function.
Are they equivalent to a tree data function?
I think so. Like tree data function goes to heads, or tree data function goes to identity. Tree data function goes to null.
But then how do you combine them?
No, I mean, this is not a tree data function thing. Have a think about it, Symbol. But I also recommend for that second argument that we have things like lists and arrays and so on.
Absolutely.
Different ways to like an import. I mean, this is basically an importer.
Mm-hmm.
This is importing from expressions to trees.
Right. We were already planning those for associations, etc. And I agree this is not the same thing. These structures select what the data is, not what you wrap the data with.
Correct.
Yes.
I think we got it.
Mm-hmm.
So, good stuff. All right. I'm going to disappear here.
Yep.
Okay. Bye.